Hello everyone. The title of this video is Complete the Square of a Binomial Expression. And in this video, I'll be working on exercises that are taken directly from a free online textbook at openstacks.org. It is their Intermediate Algebra 2nd edition text. I'm in section 9.2, titled Solve Quadratic Equations by Completing the Square. And I'll be working under the heading Complete the Square of a Binomial Expression. Now I'm only going to be working on the even numbered exercises. So in this video that's just exercise 72 and 74. And I will also have timestamps for these in the description. You'll see example 1, that timestamp will be for number 72. Example 2 timestamp will be for number 74. And you'll notice that the odd numbered problems, right, 71 and 73, have a link that you can click on and see the solutions in the text. I'm working on the ones that don't have solutions posted. And one final request is that when I bring up a new problem or start a new part of a question, pause the video and try to work on it yourself first before watching me do it and comparing. Because if you're just watching me work on these questions without practicing them yourself, chances are you're not learning all that much. Alright, so the first example is exercise 72, which I have written out here. And in each exercise, we're asked to do the following. We're asked to complete the square to make a perfect square trinomial. And then we're asked to write the result as a binomial squared. Right? So some expression with two terms, a binomial, raised to the second power. Right, like I said, this is example 1, exercise 72 from the text. Alright, so before I actually get into these questions here, let me talk about completing the square on a binomial. So say we're given the following binomial. So given binomial, right, an expression with two terms, x squared plus b times x. Right, now notice there's a this is a very specific form. And you're going to see later that in order to be able to complete the square on a binomial for our purposes, the coefficient on the squared term is 1. Right? So the coefficient of the quadratic term, right, the square term, the quadratic term, must be 1, I'll say. Okay, huge. All right, and then you have a linear term, right? So we'll have a quadratic term with x, the variable squared, and a linear term which has that same variable x, or whatever the variable is, to the first power. And the coefficient of the linear term is called b. Alright, so here's what we're going to do. So completing this square, let's put the steps over here. So first off, the expression you're looking at has to be in this form. 1 times a variable squared plus some number times that variable to the first power. And what we're going to do is add a constant. We're going to add a constant onto this to make it a trinomial. 3 terms. That is a perfect square. Right. So the first step, find b divided by 2. Remember, b here is the coefficient of the linear term. So you take half the linear coefficient, then square it. Right, square it. So that means you take half of b divided by 2, or 1/2 times b, whatever you want to write, and square this. Right. Add it to the expression. So I'll write that here. So we have x squared plus bx. I will then add half of b squared. This turns this expression from a binomial into a perfect square trinomial. Right. And that is the last part. Express as a binomial squared. So we have x squared plus bx plus half of b squared. This is equivalent to the quantity x plus half of b to the second power. Alright, and I'll let you check this. Take x plus half of b and multiply it by x plus half of b again, and do all the foiling and combining like terms. You will end up with x squared plus bx plus half of b squared, or b squared over 4 if you actually squared it. Alright, so this is huge here, right? Here are the steps. Now, I would also like to draw a picture of this, talk about why this is called, completing the square. I mean, there's the algebraic reason. When you have a binomial of this form and add the half of b squared, you create a perfect square, right? You complete the square. Now, geometrically, right, you can draw a picture representing this stuff. Where you think of each part of the expression as an area, right? The area of a figure. So if we start with, again, we start with 1 times x squared plus b times x to the first. I think of area. X squared, a figure with an area of x squared. So that, let's say this has a length of x, this segment that I just drew, and I'm drawing a square with that, with the area of x squared, right? So an x by x squared, right? So this has an area equal to x times x, right? X squared. Then, so that takes care of this term, right? The x squared term. Then I would like to add on some rectangles so that we have an area of bx. So take the length of b, we're going to cut it in half. All right, so I add on here, is a different color. Let's say that length there is half of b. And do you see that, if I just continue to add to this area, there's a length of x again. And then here's half of b, right, another half of b. This rectangle has an area of half of b times x. And then I'm going to add the same kind of rectangle over here, and I'm going to try to keep this the same length, right? So here's another half of b. Right here, there's another half of b. And here's another length of x, right? It's lined up with all these. And this rectangle that just got added has an area of half of b times x. If you take half of bx plus another half of bx, these two rectangles together give you bx, right? Half of b plus half of b is just b itself, 1b. So here we have x squared area, and then these two rectangles make the plus bx area. And now, see, look at the upper right corner, how it's blank. If I add on another half b length and half b length, right, these are again half of b, half of b. Look at what that area that got added on is. Right, this area that's getting added on is half of b times half of b. Right, it's a little square, or half of b squared. That's this term here. Right, we're adding on. Now in this picture we have added on this half of b to the second power area. And do you see what that's done? Adding this little right corner has made a bigger square, has completed this square. And what's the length of each side? Well, the length of this side is x plus half of b. And so is the length of this side of the square. It's x plus half of b. So the total area of this entire picture is, x plus half of b times x plus half of b again. So x plus half of b squared, and that's what I ended up with here. So this is equal to x plus, so the sum of these three areas is equal to this area. Right, and once again, I'll put this in a nice little bubble. Right, this is important. This is what we're going to be doing for every single one of these problems. So one more time. We're given 1 times some variable squared plus some number times that variable to the first power. Right? We're given a quadratic term and a linear term. You take half the linear coefficient and square it. That gets added. And once that is added, you've changed a binomial into a perfect square trinomial, right? Something that can be expressed as a binomial squared. And that binomial is just the variable plus whatever half the linear coefficient was, right? That half of b. So x plus half of b, that quantity squared. And that's what we're going to do for all the exercises in this video. Alright, so going back to, I'll just keep this up. So look at number 1, part A. Now it's not x, it's n, but the same setup. See, I've got a binomial, quadratic term and linear term. The coefficient of the quadratic term is 1, needs to be 1. And the coefficient here, though, is negative 16. Alright, so b, the b here from my little form is negative 16. So that first step was find half of b. Alright, b divided by 2 would be negative 8. And then square this, right? Half of b squared is just negative 8 squared, which is positive 64. Alright, so that gets added on, and I'm going to do it in a different color. So I add on 64, and now I have changed this binomial into a perfect square trinomial. And I should now be able to express this trinomial as a binomial squared. Alright, n squared minus 16n plus 64 is the quantity n minus 8 to the second power. Right, it's the variable n plus whatever half that linear coefficient was, right? And b over 2, half the linear coefficient was negative 8. So we have n plus negative 8 or n minus 8. That quantity squared is n squared minus 16n plus 64. And I leave it to you to check. All right, take n minus 8 times n minus 8 and FOIL and combine like terms. You will end up with n squared minus 16n plus 64. Right, and I'll circle this. This is what we end up wanting here. We end up wanting this binomial squared. Okay. All right, so I'm going to just do this a bunch more times. All right. So find what's the b, what's half of b, right? Half the linear coefficient. Square that. That number gets added, and then you can express the trinomial as a binomial squared. All right, so let's do the same thing here. Now we got part b. So again, same setup. We've got a binomial where there's a quadratic term, right, a squared term, and a linear term, or a first powered term. The coefficient on the squared term is 1, and the b here, the linear coefficient, is positive 15. Right, b is positive 15. Then you find half that, right, which would just be 15 halves, right? 15 divided by 2, or 7.5 if you want to write decimals. There's nothing wrong with that, as long as it's equivalent. Right, and then square it, right? Take b divided by 2 and square it. Well, 15 halves squared, 15 squared is 225, and 2 squared is 4, right? So I'm adding, the number I'm adding to make a perfect square trinomial is this 225 fourths. Alright, now that I've done this, I have created a trinomial that is a perfect square. It can be expressed as a binomial to the second power. And this binomial is simply the variable, which in this case is y, plus whatever half that linear coefficient was, so plus 15 halves. And there you go. So y squared plus 15y plus 225 fourths is, the quantity y plus 15 halves squared. And I leave it to you to check. Take y plus 15 halves, multiply it by y plus 15 halves again, and FOIL and combine like terms. You will end up with y squared plus 15y plus 225 fourths, I promise you. All right. Wonderful. All right, then part C of this first example. Same setup. You have a binomial with a quadratic term and a linear term. The variable's q. The quadratic coefficient is 1, which I want it to be. And the linear coefficient is 3/4, right? So here the b from my form is 3/4. Half of this, right? You just multiply the numerator by 1 and the denominator by 2, right? When you multiply by a half. So half of 3/4 is 3/8, right? And then you square this number, right? Take half the linear coefficient, the 3/8, and square it, you get 9/64. Right? So this 9/64 is what gets added to the binomial to turn it into a perfect square trinomial. And then after adding the 9/64ths, we should be able to express this trinomial as a binomial squared. All right, and this binomial will be the variable q plus whatever half the linear coefficient was, which was 3/8, right? Plus 3/8. Okay, so q plus 3/8 to the second power would be q squared plus 3/4 q plus 9/64. And I leave it to you to check that out by multiplying it out. Take q plus 3/8 and multiply it by q plus 3/8 again. Alright, I'm doing the same thing every time here. Right, all these are set up in a nice way where we can complete the square on a binomial. Right, so second example, which is exercise 74 from the text. See, same setup. All these are very nice for us. Right? We'll have to, in future videos, we'll have to manipulate things so we get it to be in a nice form. But I have a quadratic term and a linear term. The coefficient of the quadratic term is 1. Now the coefficient of the linear term, right, that's that b, is -6 this time, right? Not positive, no, it's negative. Then half of b would be -3. And then we square this, right? Half of b squared would be +9. Right? So that's the number that's getting added to change this binomial into a perfect square trinomial. Right? So I'm adding 9, that half of b, half the linear coefficient squared. Once I've added this 9, now I have a trinomial that's a perfect square, right? That means it can be expressed as a binomial expression to the second power. And that binomial is simply the variable, q, plus whatever half the linear coefficient was, whatever half of b was. So that'd be plus -3, right? Plus -3 or just -3. And I leave it to you to check, take q minus 3 times q minus 3 again, and you'll see that you get q squared minus 6q plus 9. Wonderful. Alright, same thing here. You have a quadratic term, a linear term. The quadratic term has a coefficient of 1, which is what we want. The linear term, the linear coefficient, which I'm calling b, has a coefficient of -7. Right, then half of this is -7/2 or -3.5 if you're doing decimals. And then you square this number. Right, half of b squared would be +49/4. Right, so we add on 49/4 to change this binomial into a perfect square trinomial. And once I've added on the 49/4, now I have something that can be expressed as a binomial squared. All right, and that binomial is the variable x plus whatever half the linear coefficient was, which was -7/2. And you can check. Take x minus 7/2, multiply it by x minus 7/2 again, right? Square it, and you'll get x squared minus 7x plus 49/4 back after foiling and combining like terms. Fantastic. Right, I've got just one more of these, right? They're all the same. So part C, we got quadratic term and a linear term like I want. The quadratic term has a coefficient of 1 like I want. Now I'm just taking a look at the linear coefficient, right? B, the linear coefficient is -2/3. Then half of this, right, b divided by 2, is -1/3, or -2/6, but that reduces to -1/3. Then this gets squared, right? Half of b squared be +1/9. Right, and that's the number that gets added onto this binomial to turn it into a perfect square trinomial. Right? So I add on 1/9. After adding 1/9, I now have an expression that can be rewritten as a binomial squared. And this binomial is the variable n plus whatever half the linear coefficient was. That b over 2 was negative 1/3. All right, and there we go. And I leave it to you to check. Square n minus 1/3. All right, take n minus 1/3 times n minus 1/3 again, FOIL and combine like terms, you will end up with n squared minus 2/3 n plus 1/9, I promise you. And that's it. That's all we're asked to do in this particular video. Now the reason we're doing this is to help us in solving quadratic equations. All right, we're going to look at a quadratic equation and set it up so that I can do this operation here, this completion of the square. And then we'll use the square root property that you've seen before to help us solve the equation in the end. All right, so I'm hoping that watching me go through these two questions with their parts A, B, and C, hoping that watching me do all this helps you in some way when you're asked to complete the square of a binomial expression yourself. And thank you very much for watching.